everybody, it's Miss Abney. I'm here to discuss example 4 from topic 1, lesson 1-5. So already in topic 1, or example 1 and example 2, we saw using graphs, both hand-drawn and done in Desmos, of how to solve these type of equations. In this one, we can use Desmos. It is technology to solve the equations, but at some point you will need to purchase a TI-84 or an 83 calculator. And so I am going to use the calculator to show you how to solve this type of problem. So here in example 4, it says use technology to approximate the solution of the equation negative x squared plus 8x minus 13, and this is equal to the absolute value of x minus 4 to the nearest tenth. So what I'm going to do is I'm going to go over to my TI-84 calculator. I'm going to make it a little bit smaller. Oh, and now you can't see the screen. So I'm going to move that over. All right, so the TI-89 calculator is a graphing calculator. It's a very great tool, and especially when we go back to school, you're going to need to purchase one because we will not really have access to Desmos. And this would be the item that you do have access to. When you take the SAT next spring, you'll only have access to the TI calculator. You will not have access again to your computer or Desmos unless we are in a virtual environment in the spring. So let me show you the TI calculator. All right, so I have the colored calculator. These are the different types that you can buy, and you could buy a TI-83. The TI-84 calculator has your standard buttons. Then we have your storing. This will come into play later on, and I'll let you know what that is. Natural log and log, again, these will come in later on. You have your exponent button here. Even though it says x squared, it would be a squared there. And then as you go up, you have your inverse button, and then the different types of math, the apps, the programs, the variables, clearing your page. These are your actual variables. I am in function form, so my variable is going to be an x. And if I type it into the home screen and I hit enter, it will give me a value because I do have a value saved in for x. You will use this variable when we're in the graphing tool. All right, so then you have your commas, your parentheses, and then your math operations here, and enter will give you the answer. Your negative button is down here in the parentheses, while this is your minus button, and then your decimal point. You could also see that above each of the keys, you have words, and they're in certain colors. So anything in blue, you would have to hit the second button to reach, and anything in green, in my case, your case might be different, and anything in green, you would have to hit the alpha button. And if you look, the alphas are A, B, C. Everything in green is usually part of the alphabet. All right, so what I want to do is I want to use this graphing technology to find where my lines intersect. That's where that equals is. This equals means that our lines are intersecting, or to find what values of x makes this equation true. So I'm going to do the y equals. And I still have some remnants of last year in my calculator. So I'm going to clear those. And what I'm going to do is I'm going to, like I've said before, we got to break this into two different functions. So I have f of x is equal to negative x squared plus 8x minus 13. And g of x is equal to the absolute value of x minus 4. And this calculator can take on absolute values. So I'm going to do the negative key again. It's the key that's in the parentheses, so negative x squared. Oh, and this little caret also gives me the option for exponents. So if it's not a squared, I could hit this caret key, and it'll put my values in the exponential place. If you notice on my TI-84, it stays there. On the 83, it will not. plus 8x minus 13. So there's my first function. The second function is my absolute value. So for this, I hit the math key, and I'm going to go over to numbers, hit enter, and there's my absolute. So again, I'm going to do x minus 4. All right, so my graph is kind of an odd graph because I have it from before. So I'm going to hit zoom, and I'm going to make this a standard graph. So this will make it a standard 10 by 10. So there's my first function, and there's my second function. I see that it intersects at 2 different places. So it intersects at this one, and this one's just a little bit off from that tick mark, and this one's a little bit off from that tick mark. So I don't have the exact values. And the way I could find where these intersections are is I'm going to hit, there's this trace button. I could actually hit that and trace. You see this little cross-haired looking thing that's blinking. I could go and I could move this to where it hits and be kind of guessing. Or above trace, it says calc, and that's for calculation. So I'm going to hit second and calculate. And under calculate, we have values, 0. So zeros are when, again, the graph crosses the x-axis. So this will tell us where the graph crosses the x-axis. This will tell us just the value that we're on. Basically, it's what the trace does. Or if I want to put x equals 5, then it'll give me the y value. The minimum, the maximum of my graph, the intersections, and this is the derivative, and this is the integral. Both of these will be introduced in calculus, so we don't have to worry about 6 and 7 right now. What we do need to worry about is 5. 5 right now will tell us where the 2 graphs intersect. So I'm going to hit 5. And now it's going to ask me here on the bottom, it's going to ask me for the first curve. What they want us to know is they want to know, hey, which 2 curves am I going to be finding the intersect of? So in this case, I can move this over, but I am on the blue curve. Blue curve is y1, so I'm going to hit enter. All right, now they're asking for the second curve. This is the curve that we're going to compare our intersection with. And so we have to make sure we are having a second curve. If I move down, then I'm back on that first curve, the y1. If I move the up arrow, then I'm back on the second curve. And I know that I do have the right curve because it's y2. And I'm just going to hit enter. Now it's telling me to guess. So there's 2 points here. And since there's 2 points here, it will get the point that's closest to the crosshairs. So I'm going to move the crosshairs kind of over a little bit. I'm going to try to say, I want to know the value of this point right here. Right now, I just want this point. In a second, we're going to get that point there. Then I'm going to hit enter. It's going to do its little calculator process, and it's going to give me the intersection point. So I'm going to round this to, I'm going to say x equals 2.697. And you can write the point down as well. You could say comma 2.697, comma, and then the y point 1.3. And then we're going to go take that second point. So I am going to hit second calc. And I'm going to go 5 for the intersect. And again, I'm going to choose my first curve. So I could actually move this over a little bit and hit enter. My second curve, we're already on there, so I'm going to hit enter. And now they want me to guess. So we've already gotten the point here. I want to get this point here. So I'm going to move my little blinky cursors over until I'm close to the second point. And again, you don't have to be exactly on the second point. It will take the point that's closer to the crosshairs. But it's always good to be pretty close, just so you're 100% sure. I'm just going to grab that over, drop it in there because I have that ability. So here is my second point. So the second point is 5.3 and 1.3. I don't know why I put a 0. I was even thinking 3. So I will be able to say f of x is equal to g of x when x equals 2.697 and x equals 5.3. So let's go over back to the book. Again, they are showing you what I showed you on my screen, and you could do this in Desmos as well. You just go to where they intersect. But again, they're using the intersect feature of the graph, the graphing calculator. So I wanted to show you the intersecting feature of the graphing calculator. They decided just to go for 2.7. I like to go out 3 decimal places. It's always very good practice to go out 3 decimal places. Oh, and that is correct. They are correct here. It is an approximation because it's not an exact. So I can't use the equal signs. I need to use the squiggly equal sign because we are approximating. We are rounding. And so approximately at 2.7 and 5.3, we have the intersect. So what are the disadvantages and advantages of using spreadsheets and Google Graph technology? Or it's a Google Graph, graphing technology. So that would be, I think some advantages for using graphing technology is that you could get the key features of the graph right away, that you don't have to do those t-tables and take that extra time. But I also think that creating tables gives a better number sense and shape of the graph, so you can actually kind of start visualizing. So hey, if I plugged in this number here, I'm going to get this number out, and I can start seeing, does a graph increase, decrease at certain areas and things like that. All right, so the next step here is the try it. So you're going to use the graphing technology. If you do have a TI-84 calculator already, I strongly encourage that you practice this problem with that. If you don't, they provide you the graph here. And you're going to, they did to the nearest tenth to keep with their way of you typing things in. I would just keep it to the nearest tenth. I personally would go 3 decimal places out because you're going to be seeing that on future AP tests. But because this is so specific on how they want you to type things, just keep it to the nearest tenth. But in your notes, I would round it to the third. All right, so if you guys have any questions or comments, please let me know. And I hope you guys have a wonderful day.